everyone. A very warm welcome. I am Jhumpa Mukherjee, Brand and Media Manager at Minimac Systems. Last year, we wrapped Series 1 in December with a lot of appreciation, encouragement, and positive feedback. So we are back with Series 2. Series 2, we are launching under Mentonia. And within this gap, we had taken a lot of initiatives towards lubrication excellence. And we have launched quiz as well, the Lube Buzz Quiz 2022. And under Mentonia, we are launching Series 2 of webinar with more knowledge and a different approach of advancement. Today, we are here to discuss a topic, IIoT, end of assumption-based maintenance era. As we know, with IIoT, manufacturing, supply chains, and maintenance practices can perform more effectively and efficiently. To discuss the benefits, the applications, challenges, and more aspects to IIoT, we have today in the panel with us Mr. Anshuman Agrawal, Founder and Managing Director at Minimac Systems, and Mr. Yogesh Kumar, Head of Technical Service Department at Minimac Systems. The flow of today's webinar will be a presentation by our experts, followed by AMA session, Ask Me Anything session of 30 minutes. Before we move further, I would like to remind you all to drop your questions and queries in Q&A box, not in the chat box. Over to you, sir.
Thank you so much, Jhumpa, for inviting us for this webinar today. And the topic for today's webinar is IIoT and the end of assumption-based maintenance. I'm accompanied with my colleague, Mr. Yogesh, for this webinar on the topic of IIoT. So I request Mr. Yogesh to start off with the flow of the presentation, and I would be joining in the midst.
Thank you, Mr. Anshuman. And really, I'm feeling very great to meet the audience after a small break. Welcome all. So we came back with a very different approach and concept. And in this season, we will be driving the things like a fairy tale. We are starting with IIoT. This is not simply IoT. So what changes we are expecting in the industry and what should be there? We will be going through all the points and especially what we can do best for the equipment reliability, sustainable development, and safety. So one by one, we will go through all the aspects. Sorry. So as we mentioned in the heading itself, this is end of assumption-based maintenance practices. Assumption-based maintenance practices is nothing but what we heard always from our elder or seniors, that I have experienced more than what age you are, or how old you are. So this is nothing but completely experience-based maintenance. It sounds good that experience matters, but that is not always true when technology is there to go in depth for a condition monitoring system. So in this era, or the era we are right now, or we were, is almost 5 types of maintenance practices have been evolved, like reactive maintenance, predictive maintenance, preventive maintenance, condition-based management, and prospective maintenance. So reactive maintenance is the firefighting mode of maintenance. We have to rush without seeing what was the reason. Just quench the fire and move ahead. That is the firefighting mode. Then something next type of maintenance came into picture, that is predictive maintenance, where we take certain parameters or we choose some values, those are important to be monitored. Then okay, now we can at least do some advanced maintenance before it fails. Very good. The question mark remains there that those parameters, whatever we have chosen, are really sufficient, or we can do better in that. That we will see later. Those parameters like pressure, temperature, vibration, are they sufficient? Probably not. We will see how. Then the next step we gone for preventive maintenance. Very good. Now we made a schedule. Even if equipment is running good, but timeline has reached, we have to go for preventive maintenance, like we do servicing of our vehicle on certain kilometers or certain days, months, we do maintenance. So that is preventive maintenance. Sometimes it's very useful, sometimes labor goes in vain. Maybe equipment is very healthy, still we have to do the maintenance unnecessarily because the timeline has been met. Condition-based monitoring. Condition-based maintenance, when we talk about this, then we have a schedule to do routine inspection or routine check with the help of condition monitoring equipment like vibration analyzer, temperature gun, or ultrasonic detectors. We do condition checking, and based on the outcome, we do maintenance. So this is fourth part of maintenance, and the latest one, what we are following now, is prospective maintenance. This perspective word is evolved long back. It is just like when we see the railway track, it seems to be merged at a certain distance. When we see a railway track, it looks like that they are converging together after a distance. So this is nothing but we are guessing, or visually we assume that they will not meet. Next slide, please. Yeah. So this perspective-based maintenance is a technically very right way of maintenance practices. Here, we do synchronization of different methodology adopted in the routine maintenance, and the approach what we adopt is not only assumption based or just machine output or condition monitoring based, but we synchronize them. This is the time beyond this assumption. Now, no more assumptions, no more experience based maintenance, but the technology will say what to do, what not to do, and that will not be outcome of a single logic, but that will be outcome of lots of philosophies incorporated in that logic. That is our IIoT based maintenance. Again, I am saying this is not IoT, this is IIoT. Let's see what is this. This is a diagram about evolution of maintenance practices. As we invented wheels, then that is the first machine developed by a human being, then finding the fire is the revolutionary finding. Like that, in the maintenance, although industrial revolution was the concept of 18th century, and after 3 more centuries, we are talking about maintenance practices. So we are running a bit late than the industry requires. So like in the 1970s, we started reactive maintenance, run it till it fails. When it fails, we will rush to the site to maintain it. Then it came to preventive maintenance, stop the failure. Then in the 1990s, condition-based maintenance like shock pulse meters and other things came into picture. In the same time, predictive maintenance also has been introduced because when
So I will continue if Mr. Yogesh video is frozen. Hello, Mr.
the
Yeah.
condition monitoring equipments were available, then why don't we use it for a routine checkup?
Mr. Yogesh, your audio is not clear. So as we were talking about various types of evolution which has happened with regards to maintenance practices.
Mr. Anshuman, I'm back.
Yeah.
Can you hear me, please?
Yeah, please continue.
Yeah, so sorry, there is a network glitch and I was not able to overcome it.
Okay, no problem.
Yeah, so when I was just talking about condition-based and predictive maintenance. So if equipments are available like stethoscope or BP monitoring equipment, why we are doing it on a general basis, like monthly we will go to a doctor to check our blood pressure. Better to have equipment at home, and can it be done on the daily basis? This is the matter of same year or same era. Then in 2000, it was a revolutionary year for maintenance because prospective maintenance came into picture. Okay, now we are talking something about automated maintenance practices like live data recording, live data analysis, alarm generation. Alarm generation having 3 parts: normal, moderate, critical. When it reaches to critical, then immediately it will draw our attention because someone has fallen in the basket of critical. So in this era, we were very happy, and nowadays maximum industries are running based on this maintenance practice. Then prescriptive maintenance is a concept which was working well. Now we are entering the new era, that is cognitive. In the cognitive maintenance, now we are implementing the decision-making capability to the equipment. Even if we don't recognize the extent of criticality, machine itself will diagnose and it will take itself action to overcome it. Is it really possible? Yes. how we will see it. So this is chronology of maintenance practices, and this is a graph which is very popular. And if we say if we see the graph and we find the break-even point, then it is somewhere very much in the right. But in cognitive maintenance era, the cost of repair is here something like a not exponential curve, something like hypoid. Now it has to come like asymptotes. The y-axis will meet with the cost of repair. So cost of repair will be minimized. As I mentioned, it will be something like asymptotes in the terms of mathematics, and how it will come, we have to visualize it, we will see it. Okay, yeah, now it's time to see the interest and participation level. A poll question for you. Which of the following maintenance practice is broadly adapted in your industry? Please be open, share, because we are not an evaluator, just wanted to know what type of practice, and please answer in the poll so that we can see the right picture. Replying in a chat or Q&A box may not be helping much. So options are predictive maintenance, condition based, perspective based maintenance, or cognitive. Let us, those who are answering in chat box, please reply on the poll. Oh, great. We have the answers here. Technical team, can you please, for example, yeah, right. So condition-based maintenance has got maximum voting, that is 70%. Of course, very correct. And this is the real picture. So, and especially cognitive maintenance is 0. That is quite alarming. Anyway, so condition-based maintenance is adapted because it was very easy to adapt and low-cost maintenance practice. And IIoT is next generation maintenance practice, which will be much more cost-effective than this. Cost-effective and cost implication is two different aspects. So IIoT will be much more cost-effective. We will see it. In upcoming slides, we will see how. This is something we face daily. Problems like oil sampling error, because who will take the oil sample? Not the maintenance in charge, not the maintenance engineer, but someone down the line will go and collect the sample. He is not aware that opening of the bottle and closing the bottle cap is how much important to get the right sample. For or in his perspective, it is just to fill the bottle with the oil. Then second point will be time for the result. Yes, sample bottle will go to lab. Lab has number of work. Sample will be there in the queue. It will come after 1 day, 2 days, or a week to testing. Then result will come in mail, maybe another 1-2 days. Till the time machine is struggling. If sample result is wrong, means the sampling time was the alarming time, and still machine is running with the wrong oil. So we have lost 1 week or more than that just because of testing lead time or test procedure, then expensive always. We have to have a manpower to take the sample. We need a special manpower to go to lab. Then again, the test data interpretation, we need another skilled manpower. So these are very expensive procedures, no doubt. Then monitoring the equipment manually. Of course, the entire process is not automated from the sample to the test result interpretation. Everything is done by a human being in the manual way. Prediction and assumptions are always confusing. For someone, NS class 5 is okay. For someone, that may not be okay. Because based on his experience, he is interpreting. Like that, there are a number of parameters. Those are assumed based on their experience or based on their training. So these are the loopholes in our daily maintenance practices, and these are the root level problems. There are a few more problems we will see in the next slide. Yeah. So already talked about high number of workforce is required. Then training requirement for the workers, that is not always possible because they keep on changing or in the routine changeover of their responsibilities. It happens. Again, lack of proper infrastructure is the noticeable point. Why I'm saying it? Lab is a word when we say we have a lab. Lab has certain parameters. Taking an equipment and putting on the table and in a room, we can say it is a lab. No. Lab has to be properly organized, properly assembled, and properly maintained. The environmental condition, the temperature, humidity inside the lab, the cleanliness of lab, there are many things. So infrastructure plays a vital role. Operational costs, definitely, we talked a lot back that not only manpower cost, but manual intervention itself. How far is the lab? Are we going for third-party lab testing or we are doing it in-house? So there are many restrictions in this. Then fear of sudden breakdown, it will always there whenever human intervention is there. We are thinking as a user, if you think I have done my job best, now I can sit back and relax. But we don't know the responsibility handed over to the next person is equally responsible or equally qualified, trained. No one can say it. It is very easy to maintain a machine than a human being. That's why organizations have HR managers. So fear of sudden breakdown will be there always, and this is nothing but sleepless nights for a maintenance professional. How we will see it? Next slide, please. Yeah, we have just seen the evolution of maintenance practices. This is just what is IoT and what is IIoT. This is just a glimpse for that. First, I will be for the industry. So till the time industry 4.0 was not 4.0 or 4.0 was not evolved, we were not knowing that is there any revolutionary number for the industry 1.0, 2.0, 3.0? Probably almost of us, I include myself as well, we were not thinking over these numbers. What is revolution number? So if we see the picture, see how old this is. More than 250 years. So in the 250 years, I was just mentioning about the industrial revolutions that started from Britain. That's why Britain started capturing the other countries to sell their products. So after industrial revolution, that was industry 1.0 or 1.0. So starting from that point, we started our journey. It was not structured or framed. That's why we were not aware of that generation number, that is 2.0 or something, 1.0, 2.0, 3.0. Then in 1870, when Britain was almost leading half of the world, that time industry 2.0 was on the peak when we started batch production, mass production, line production, like we do in automotive industries nowadays, automobiles, line production. Those are concept of that era, industry 2.0. Now 3.0 came into picture when robotic arms came into picture. For the welding, for the pick and place robots or shifting robots, they came into picture in the industry 3.0, that is mentioned here 1969. And that was the time when already UNO was formed and NATO and other things were in the picture. Means globally we were coming together to help each other, to support each other, and to grow together. That was the era. So with that concept, this automation has come into picture. Then when everything was automated, what was left? Something was left. That's why this 4.0 is here. This is nothing but a concept for minimal harm to the human being, minimum physical stress or mental stress to the human being, and everything over the cloud. Everything will be there on the sky, and anyone who is able to access the data can download it. Yes. So now I just wanted to float this question that how many of us were aware about this industry 1.0, 2.0, 3.0, 4.0? Just say whether we were aware of this entire revolution or not. This is the question. 4.0 is known for everyone, no issue. But were we really aware for the 1, 2, 3? Certainly surprising. Looks like I was not aware much. 64% voting is there. Yes, they were aware about 1, 2, 3. Wow. Means our audience are much more aware that we are talking today. it's really appreciable to have a great audience like you. And yeah, so let's see Industry 4.0. So in the 4.0, it is integration of many things, starting from human aspect to the machine safe most operation aspect. Like equipment should run safe, human beings should be safe, it should be much more automated. Monitoring tools were there in the field, and now outcome will be based on sensors and cloud. Then quality of data, there should not be transmission loss or data loss. So now we can monitor thousands of equipment in single click, and within a second we can see that how many are there in good zone, how we are there, how many of them are in the zone of alarm, or how many are in critical zone. With a single click we can see them. This is completely network based. Networking is important always. Whenever we talk about integration, then networking is there in picture. So everything has to be tied up with a thread that is nothing but network. So industrial IoT is really IIoT. That I is for industrial, and Internet of Things is IoT. That is very common word nowadays. Yeah. Next slide, please. Yeah, this is the picture of IIoT. So this IIoT came later than the IoT, because IoT was somewhere we started using OTT platform nowadays. Apart from the channels, somewhat like that, IoT was there. But this IIoT is a different concept than IoT was formed. Now we have technical data, technical things on our fingertips, on our palm top, even not on the laptop. It is available on our palm top. And for a successful business is not an entrepreneur is doing. No. A maintenance guy has a business to safeguard their equipment. His subordinate has a business to safeguard a particular section of that equipment. So everyone is doing a business. That is their responsibility. This IIoT plays a vital role thereover, where wireless communication and analysis of data is done in the automated manner. Everything is there on the sky. Anyone can access, and calculation is done somewhere else in the cloud. We have to just see the picture of the final outcome. We don't have to go into calculations. This is the basic concept of IIoT. No need to break our brains behind the data, behind the calculation, because data are not in dozen or in hundreds or in thousands, they are in lakhs in numbers. So analyzing all the data, all the values, bringing them together and getting a final outcome is the role of IIoT, and that final outcome should, in the way it can be accessed anywhere on our palm top. Next slide, please. Yeah. So this is a slide explaining about IoT and IIoT. Just we talked a lot over this. So suppose sitting at home, if we can see, suppose no one, means suppose I am a maintenance guy, or any one of you is a maintenance guy, sitting at home, just open one app and see machine condition. No need to go into the parameters, because one machine has number of parameters and we have hundreds of machines under us. Just by opening the app, just you get one notification, this machine is in yellow zone. You don't have to think about remaining machines. They are happy because notification is for one machine. And if you touch that notification, you get that one of these parameters are not or is not in the set range or not within the limit. Immediately we can take action, we can make a call to the related person. Suppose machine vibration level is not in line. Immediately we can ask C&I guy, go and check physically whether sensor is malfunctioning or it is the real problem. After that, we are comfortable. This is the concept behind this IIoT. Make the life simpler, spend the life with family, not struggle hard to get information directly from the machine. So these are a few benefits listed here over that what IIoT can bring or can do a change in our life. That back please, back. Yeah. So I will mention about the central point that asset tracking is another IIoT part. Asset tracking, this is the most important nowadays, because asset saving, asset monitoring is vital. Asset may be a machine, maybe our car. That's why we have remote sensor in the car. Someone or some unwanted person tries to open it, there will be an alarm. That is nothing but asset tracking. So this is gift of this IIoT about all the systems we have. Next slide, please. Yes, everything comes with a cost. That may be monetary cost, or that may be in terms of risk. Yes, IoT is definitely vulnerable. When you are posting your data over cloud, anyone can try to puncture that cloud and get the rain. Entire data will flush over him. Then what to do? Yes, our account is now online. Bank accounts are online. They are made secured enough by several mechanisms. Only authorized person can do the transaction. Only authorized person can see the details of data. It is same way applicable to IIoT. A roadside person cannot check our data. A burglar cannot tamper our data. And a notorious person cannot hamper the data collection. Risk is there, but solution is ahead the risk. Solution is right now available. Before we implemented this IIoT, solution was ahead than that. So nothing to worry. Poll question number 3. I would like to invite Mr. Anshuman to carry out this poll question. and to carry out this presentation forward. Please.
Thank you so much, Mr. Yogesh, for assisting me with the presentation so far. So I would like to know from the audience, how have you utilized any of the benefits of IIoT for maintenance practices? If you have already started implementing things around it, or you have certain plans ahead, you are exploring it. So please be very wise in terms of your responses. Based on this, we would understand what is the situation right now with regards to implementation of IoT at various locations. So can we have the results of the poll if people have already polled? Okay, so as I understand, yes, there are a lot of people who are exploring right now, and possibly they are still understanding on how to implement it, what to implement, how to actually have the execution plan around the IoT. So this is what we would like to answer in the upcoming slides, and I hope these slides would be beneficial for you guys when you are going ahead with your IIoT program. So what are we doing right now? As you see this slide, there are too many things we are doing right now. We have multiple analysis equipment, multiple monitoring equipment. We get so many reports at our table or onto our PC, the online reports, offline reports from various sensors and instruments and analyzers. So too much of data is coming to us. And I personally believe that it becomes difficult for us to analyze and actually get some positive insights out of the data if the data is too much, and if the data is not classified or it's not structured. So this is what is happening right now, and we are all confused. So that's the area where we can have the IIoT, because when IIoT comes in, it would have an automatic check over the oil purity levels. It would have an automatic purification activity which can be implemented, and it can also have an automatic power off if there is any situation of emergency for your equipment. So we are talking about something which is totally automatic, where no human intervention would be there. And how are we going to do that? So there are basically certain instruments which are used for carrying out certain activity of measurement of various oil parameters, like the one which we are showing out here. It's a particle counter, a laser particle analyzer, which is IIoT-enabled, and it can actually sense the various levels of contamination. It can give out the data using the Wi-Fi or using the wired networks or communication channels to the cloud system. And from the cloud system, basically, a platform can be built where you can check the alarms, you can monitor the data, the trend, and you can take actions accordingly. So how is it going to be implemented? How is the IIoT plan structured ahead? The first thing is asset selection, because it's very important to understand that IIoT will come at a cost, and it will be an overburden for you in the coming days. But do we take it as a burden, or do we take it as an asset for us, which will help us to control our costs ahead and control our maintenance practices ahead? So that's certainly very important to be understood. So when we do a structured planning around how are we going to implement IIoT solutions, I am very sure that you can come out with a cost-efficient solution. And by cost-efficient solution, I mean to say, probably you would have to classify your entire asset list into highly critical, critical, mid-critical, lower critical, and non-critical. And this is the way how probably you would be able to implement the IIoT solutions for your plant activities and for your assets. So right now we are doing condition-based monitoring, where we are doing smart replacement, we are recovering the revenues, we are having our assets, we're having a better availability. The workforce engagement is getting improved. We are certainly decreasing the maintenance planning. We are trying to implement the IIoT things, and we are certainly reducing the service losses and lowering the risks. So this is what we are doing right now with condition monitoring. Now, what we are talking about is a paradigm shift from condition monitoring to condition management. So what is condition management? The condition management revolves around having condition monitoring as an input. How does this input come in? So this input comes in with the lubrication data. That is one package of it. That lubrication data can have fluid property data, various parameters of the fluid, like the contamination level, the moisture level, the fluid oxidation levels, wear metal analysis levels. So all these data, whether they are offline or they are online, they all form the fluid property data. Second comes the pressure and the temperature data, which is the operational parameter of your equipment. The third comes the inspection data, because you might be having a walk around inspection of your equipment daily basis or a weekly basis, or even you might have certain maintenance schedules on a monthly or quarterly basis. So all these inspection data, they can certainly be acting as an input to the condition monitoring package. And also we have a lot of portable data collectors, which our people would be using while they are performing the various walk around inspections of the equipment and the assets. The second package of the data is with regards to the other reliability parameters like vibration, speed, acoustics, position and motion, thermography, and the motor current control. So these form a part of your entire condition monitoring data. And I'm very sure a lot of you are already using various sensors and methodologies and programs to collect the entire condition monitoring data. So after this condition monitoring data is collected, it has to be used for analysis. And once you use for analysis, there should be certain insights coming out of it. And those you can say as condition responses from your human side. So this is something which is already getting implemented. A lot of industries today are shifting from condition-based monitoring to condition management, using those data which are coming from the condition monitoring systems and programs. Now, what are the elements of condition monitoring under IIoT? So under IIoT, what we are proposing here is that a lot of data would be collected by the sensors, and these sensors are all IIoT sensors. These will be the sources of data. They would be doing a real-time monitoring of your assets, which are highly critical assets. And these sensors would be collecting the data. They would be transferring this data by networking devices or channels using Wi-Fi or cellular or wired networks. Once these data have been transferred by the networking methodologies, there should be a collection of the data. So with regards to collection of data, you need to have a program with regards to the update rate, and there you would have certain edge computing where you can actually collect the selective data. After the collection of data, the next step is storage of data. So for the storage of data, you need to have a well-secured cloud platform. Either it can be a cloud platform or it can also be an on-premise server. But probably the on-premise server would be a costly affair for many industries. So that's why cloud-based platforms, which are shared resources, they have been very commonly used in the industry right now for the storage part of the data. Once you have stored the data, the next part is analysis of the data. For analysis of the data, today we have got a lot of tools with regards to AI, that is artificial intelligence. And this artificially intelligent system or management, it would have alert. Alert means red flags or green flags or yellow flags. So these alerts would be classified based on the incidence level. And too many alerts also are many times not very preferred. So the alert system of all this AI-driven data system, it should be very, very friendly to the users, because the user would never like to have too many alerts popping up their screen on a daily basis when they start up their work. So the alert system should be selective. People who are working down the line on the equipment and they are handling just the solution of the various parameters going deviated, for those people, number of alerts can be higher. But for people who are into multitasking and multi-activity, like a management-driven person, for them, the alerts can be selected. The next portion is machine learning. So while a lot of data is regularly coming to the entire cloud system, and a lot of activities are being recorded on it, with regards to how the parameters have deviated, what actions were being taken by the users, how the inspections have happened, how the solutions to these deviated parameters were taken. Once all these data are fed into the system, the machine learning process starts happening. And once the machine learning starts happening, the equipment actually starts gaining a natural experience that a human being normally gains during his or her course of career. So what we are doing out here is we are drawing out instances from various incidences around, and based on those incidences, a learning based understanding of the equipment is happening. The equipment, the cloud system or the platform of IIoT, it is learning more and more on a day-to-day basis. So that's why we say the early you enter into IIoT, it will be better for your industry to adopt the best of AI and the best of machine learning in the years to come. After the machine learning stage, it's the cognitive translation to the task stage, where the machine starts giving out various insights. It starts giving you responses. The platform which is being used for the IIoT, it starts giving you understanding on why the system failed, why the system might fail, and what is that you can do so that the system doesn't fail in further. And the next step is, of course, the augmentation of the people and the processes. So the entire system of this IIoT has got 8 different elements, which are very important to be understood. And whenever you install or apply any IIoT based platform for your plant or your machineries, these 8 elements would form a basic course of understanding for you. So here we end our talk on this IIoT based maintenance activities. And I would like to certainly go back to the host to take the proceedings forward.
Thank you, experts, for such a great presentation. So you can get in touch with us. Our email ID and website is mentioned on the screen. So stay tuned. We will see you in the next webinar the next month. And don't forget to register for it. Thank you to all the experts. And
thank you so much, Jhumpa, for inviting us.
Yeah. Okay. Thank you. See you soon.